Hey there, Vince here, and welcome to a very janky circuit rewind.
What is this for?
So what is with this really weird setup that I have on my desk right now? My very jank test bench setup of a very old computer. On a recent episode of Craft Computing's Talking Head, someone in chat mentioned the existence of a PCI Express card to PCI slot adapter. When Jeff loaded it up on the screen, I kind of recognized the adapter. And then it occurred to me, and I went and looked through my inventory. It turns out that I had already purchased this adapter years ago. Why did I purchase it? What did I purchase it for? Heck if I know. I don't remember. I never used it. I just love having really weird esoteric adapters in my collection. And this seemed to fit it quite well, and it was cheap. So during that episode of Talking Heads, I went into my inventory and found the adapter. I then spent all evening trying to get it to work with little to no success at all. I first tried it with the RTX 3080, and it got as far as detecting the card, and then the operating system would immediately crash. I was later testing it with a bunch of older, lower powered cards, like a GT210, and some various AMD cards approximately the same era. I think a Radeon HD 6770 was one of them. And all of them failed in one way or another. Tonight I came back to the idea and remembered that in my arcade cabinet, there's an ITX computer in there that has an NVIDIA GT1030 in it. So I pulled that video card out of the arcade cabinet and brought it over here to the test bench to see if I could get it working. So this is the adapter right here. I first tried the video card in this adapter and it was getting the same corruption as before. So one of my thoughts was maybe this adapter was not applying enough power, even though this is like a 30-40 watt card, like very low power. I decided to put it on one of these crypto mining adapters that I got in the crypto mining crash. Similar reason, I buy random weird esoteric things just to have them, because this has its own power bus rather than pulling from the PCI slot. And this is powered right now through a SATA power connection, but it also has Molex, or can take a 6-pin PCI Express power connection. This connects over here through a 1X PCI Express link using a USB 3.0 A to A cable, which is perfectly fine because this adapter here, even though it's a 16X slot, only has 1X populated, so we're not losing any bandwidth from this adapter at least. Additionally, even looking it up, PCI Express 1.0, a 1X lane is still faster than a PCI slot. So we're actually losing no bandwidth whatsoever with any of this PCI Express stuff going on. It's running at basically the full bandwidth of original PCI. The only caveat to that is that PCI is a shared bus. So like on this board, there are 3 physical PCI slots. So if I populate all 3 of them, they all share that same bandwidth, unlike PCI Express where each lane has its own dedicated bandwidth. So you may say, oh, there's only one card in here right now, it has all the bandwidth. Well, that may not be the case. So when you look at things like the onboard audio, the onboard USB controllers, the onboard SATA, things like that, some of them actually run still through the PCI bus. On this particular board, I'm not sure, I haven't looked at the diagram, but there's a chance that this SSD drive or the sound card or something else on this board may actually be sharing the bandwidth with this video card, which is part of the reason we get stutters and things like that. But then again, we're going to get stutters anyway because it's a very low power card, and I haven't talked about the rest of this board yet and what's going on with it. Here's one of the sticks of RAM. I had to take it out to make this system work. I thought I had 32 gigs of RAM for this board, but it turns out I had a pair of 4 gig sticks, so only 8 gigs of RAM, and that's when I was getting the corruption. Not be the case. It occurred to me because this is an older slot, and if you know about things like, we talk about today with resizable bar, back then it wasn't resizable. The bar is still like a method of transferring data from system memory over to GPU memory and how that's addressed and allocated. Having more than 4 gigs of RAM meant you need 64-bit addressing to be able to access all of that memory. And so, based on a suggestion from the Craft Computing Discord, I dropped this machine down to only 4 gigs of RAM, which also drops it to single channel. And lo and behold, this card is now finally stable. which means that some of the other cards I was testing previously may also be stable with 4 gigs of RAM on the motherboard. This is DDR3 RAM. I think it's running at 1333 megahertz. The CPU is an Athlon 2 X4 640, so that's 3 gigahertz per core, quad core. And, you know, those numbers sound okay with, you know, compared to today's systems. Like, it's not super slow. But when you actually look at the IPC difference, this chip, all 4 cores combined, is still slower than 1 core on a 5000 series Ryzen chip, maybe even a 3000 series Ryzen chip. So yeah, the IPC has really, really changed in the past decade or so since this was a platform. All right, let's see if we can game on this setup now. The first game I'm going to try is called Ink, just a very simple, basic 2D platformer. This game has no requirements at all, basically. So far, menuing seems to work just fine. And we're using, the game's running at 30 FPS, which I believe is the native refresh rate for this game. GPU is using 15% power, CPU is at like 20%. Yeah, this looks like it's working perfectly. Also, I love indie games and puzzle games, things like that. I've always loved this game. Basically, the whole world is blank and you have to go and spew paint all over the place to see where the walls are actually at. How'd I screw that one up? It's so easy, you just literally hold right and you just fall right in, and I screwed that one up. And then as you progress through the game, you'll eventually get harder and harder obstacles. Like now we have enemies, and you have to clear out each enemy before you can complete the level. Ooh, now we're getting some lag. There we go. Okay, it seems to be working a little bit better now. It may have been just loading the audio files for the enemies. All right, let's call this one good. The next game I'm going to try is called Horizon Chase Turbo. It's a 3D game, but it'll run on a potato. This is a ported cell phone game, so it should not require much at all. This is normal for it to be a little choppy as it's loading. We are running on a 75 Hz panel, so having this game run at 75 FPS means it's perfectly V-synced. Let's go in and check our graphics options just to validate that. So yeah, we're running at 1440p with VSync on a 75 Hz panel. We are definitely maxing out the GPU on this. Also, a GT 1030 at 1440p it's mind-boggling impressive that it can even do that, regardless of, you know, the jank interface that it's running through. And we're still getting, you know, 49, 48 frames a second doing this. What's a 1440p graphics card in 2023? A GT 1030 running on a PCI adapter. All right, let's go play around with another game. Let's get out of this. All right, let's test out, as you can see, Ultra Street Fighter 4. Yeah, I know, Street Fighter 6 just came out. I'm not going to take the time to go on and X out of here and try to load that up again. Basically, that crashed to desktop, and from what I can tell, it crashed to desktop because there wasn't enough system RAM in here. I tried it a couple different times. I rebooted the system and disabled all startup applications and loaded it up again, and I got further, but it would still crash to desktop, and I apologize to the Capcom developers because it also sent a crash report. 4 gigs of RAM is not enough to play the game, and I accept that. All right, so Street Fighter 4 here, I'm running at 1080p options and, I don't know, some medium quality settings. Oh, this is chonky. Oh, that is chonky. That is slow, 33. Audio and video is nowhere near in sync, and those animations are super slow. The game is running at like half speed. All right, so we're still on 1080p, but dropping everything down to low. Okay, yeah, this is definitely responding much better now. Hey, look, it's in sync. All right, cool. So just changing a few settings, and we got 1080p working on a 1030 with the jank setup. Let's see what else we can do next. All right, now, let's see how Unreal Tournament 3 does. It's another D3D9 title, and we're playing only at 720p because, well, the GPU is what's getting taxed the most. And we're sitting in the mid-upper 20s for frame rate. Okay, maybe now not that we're playing. Hey, look, I got one. This is super chunky. This will never get old. It's super chunky, but I'm getting my headshots. Mega kill. Okay, enough of that. But yeah, GPU-MEM, it's a 2 gig card only using half a gig. CPU, or yeah, system RAM though. You can see 4 gigs just isn't enough for anything. Even an old game like this. Like I said before, I like simple games, whether they're indie or commercial. And in this case, Pac-Man 256, if you haven't played it, is my favorite iteration of Pac-Man. The whole premise of this game is, in normal Pac-Man, there is the ending level 256 where the game will just crash because it doesn't know how to load a level of that number. The entire premise of this game is based around just that one concept, where there is corruption loading from the bottom of the screen and you're trying to escape it. Not getting full frame rate. We're in the upper 60s, but this is most certainly playable, especially since this is a slower paced game anyway. Yes, we're talking about frame rates in a Pac-Man game. We're back up to 75 frames a second though in this area. Ooh, this is gonna be fun. I love all the power-ups in this game. What? I didn't even see him there. Oh well, that's Pac-Man 256. Very playable on this at 1440p. Testing one final game here, Doom 2016. Let's see if this runs at all. So far it's taking a little bit of time to load. Our progress bar is slowly chunking away, just past 69%. Nice. Chunky, chunky, chunky. Okay, I can hear Mick Gordon's music at least. In the corner, it is reporting 2 frames a second right now. Let's see if we can get into a settings menu. Notice, warning, modifying advanced settings may adversely impact performance. We're at 1 frame a second. Please let me in here so I can drop it to the absolute worst. Okay, so we got this up to 30 frames a second, dropping all of the quality details to the absolute minimum. For reference, this is what really slow storage looks like. I won't even get into what I'm actually storing these games on right now. But it's worse than you can think. Okay, now we're sitting in high teens, low 20s. It's not great, but this is definitely playable. The pixel count looks to be about that of the original Doom. And there you have it. Doom 2016 is chonky as hell. Let's try running the Firestrike test. This will probably be one of the lightest tests that is still in the current 3D Mark suite. For this test, I've set it to run at 720p, widescreen, bilinear filtering, anti-aliasing is disabled, and pretty much everything else is set to minimum values. Let's run this as light as possible and just see how the test performs. This is taking a lot longer than I expected. This is chonky. All right, let's see what kind of result we got here. A graphics score of 2368, a physics score of 4000, a combined score of 476. All right, with those numbers, let's go swap this config around and see what happens on having it directly on the PCI bus, or PCI Express bus, I mean. So at this point, with me putting the card back into the PCI Express slot and not using the PCI bridge anymore, I could technically put the other stick of RAM in there, doubling our RAM back to 8 gigs and making a dual channel, but I want this to be a like-for-like comparison. Oh, my screen flashed there. I want this to be a like-for-like comparison, so I'm going to leave the configuration exactly like it was, other than moving the card from one slot to another and running those same benchmarks, or the one benchmark again to see what happens. 3176, 4247, 615. Dang, this is a much higher score. So yes, the Jenkinator hurts performance a lot, even with this silly little GT 1030. That's really cool to see, actually. I did not know it would be that much of a difference. I thought it would be a hell of a lot closer, so quite impressed. Quite impressed. Ugh, that was weird. Interdimensional spatial travel of some kind. For me, it's the next day. For you, it's only been a couple seconds. And now I'm back to benchmarking, just testing a couple more ideas out. Right now, I'm not using the PCI adapter anymore, but I wanted to see how this card performed, still the GT 1030, with only a 1x PCI interface. So I'm using the external PCIe adapter, the old crypto mining adapter, to see how this thing would work. And with that, let's quickly run down some numbers. 3129, 4233, and 606. So still definitely better than our PCI device. Cool. Okay, now the fun one. Earlier I mentioned that the RTX 3080 did not work on this setup. However, when I was testing that was before I dropped the rig down to 4 gigs of RAM. The rig is still at 4 gigs of RAM. The 3080 is now plugged in. I had to swap power supplies to get a more powerful power supply to support this. Also, this is a modded 3080. It has no fans by default, so I had to add some jank fans to it just resting on top of it. I have no idea if this works. I have not powered this on yet, so let's go. Get the power supply turned on and the magical LTT power button. Get that turned on. And let's see if I even get a screen. I have no idea. Okay, we at least get a screen. I did get this far before, but it would crash in Windows. It may load normally the first time because it may be loading into the generic Microsoft display adapter driver, not the actual NVIDIA drivers. So when it was in that mode, it was working, I believe. Yeah, this is acting like it's the Microsoft driver, not the NVIDIA driver. So we'll have to get the NVIDIA driver loaded up first and then see how well this actually performs. So it is detecting that it's a 3080, but it says the driver needs to be reinstalled. And it did it on its own. We have a RTX 3080 running on an old 32-bit, 33 megahertz PCI slot. Okay, let's see what we can do with this now. I'm just gonna start back with 3D Mark. And this time, I'm not gonna keep it fair. I'm not gonna downgrade the quality settings on the GPU. I wanna push this thing full bore to see what happens. Okay, so we're back in 3D Mark here. I'm gonna very slowly go to benchmarks, scroll down here, please work. Too far. Let's go to Firestrike. I'm going to run a 1440p test so it's native to the monitor. Maximum everything. I mean, this is a 3080. Granted, everything else is jank, but this is a 3080. It should be able to do anything, right? I'm going to be quite honest with you, I'm impressed. This is significantly further than we got before. Like I said, with 8 gigs of RAM, the driver would instantaneously crash, and each time it was a completely different blue screen message. It wasn't consistent at all. So we're in Windows, things are running, and we're actually loading a benchmark, albeit very, very slowly because, again, this is the Jenkinator. So the RTX 3080 on the Jenkinator, fully maxed out settings on the Firestrike demo at 1440p, graphics score of 5902, physics score of 3068, and a combined score of 1545. It ran. What the hell? All right, one less test for today because I don't want to spend all day playing around with the Jenkinator and watching progress bars indefinitely. Let's see if we can get Doom 2016 running, which we know it should because the 1030 could run it. This is taking a while. Granted, this loading screen is running at 42 frames a second, but I cut the video a little bit. I left, I went and watched some YouTube videos, I had some snacks, I've done a bunch of stuff. It's been at least a half hour, maybe an hour that it's sat on this screen at 80% loaded. It hasn't budged. I don't think it's working. But that's also because, like I said, I put it to ultra settings and it may have exhausted the 4 gigs of RAM on the main system, even though the GPU is perfectly fine. Okay, I take that back. Well, part of it. It turns out Windows, I went and did a quick little deep dive, was only allocating about 3.5 gigabytes to a swap file. So I forced that to be 12 gigabytes. I had to delete some files to make that happen because my solid state drive here is only 60 gigs and Windows uses about 40 of that by itself. And if you're curious how I'm running something like a 60, 70 gig game on a drive that small, well, I'm not. I actually have an iSCSI share running off of a server in the closet is how I'm handling all of this. That way nothing's actually installing locally. Yeah, that's slow. It's painful. It's part of the Jenkinator. I was just too lazy to find a large storage drive for the system when doing this testing because I initially built this for something completely different. And I'm like, well, since the board is sitting here, let's try it out. It wants me to press space to continue. Please. And what am I getting? It's low 20s for frame rate. But this is also, again, the Jenkinator on an RTX 3080. 1440p with ultra settings. That just feels slow. Like, I wonder if the engine is actually not running properly. It looks pretty though, that's for sure. Okay, dropped it down to medium. And we're, what, in the 20s to 30s? Like, I bet you anything we are CPU bottlenecked and not even anything else. All right, so I think I'm gonna finish this one up. Should you do this? No, this is dumb. This is all kinds of dumb. This is the Jenkinator. This is the Jank Station. It plays games very, very terribly. Frame rates are horrible, but they do run, surprisingly enough. With only 4 gigs of system RAM, everything is terrible, especially with Windows by itself using half of that at least. And everything is slow. I don't have much else to say about this, but don't try this at home, except, I don't know, if you really want a bad experience gaming. Anyway, that's all I got for now, so until next time.